Welcome. Today we'll solve a problem involving Coulomb's law and the force between two-point charges both in free space and in a dielectric medium. Let's start by looking at our problem. We have two-point charges, one charge of 20 microcoulombs and another charge of 10 microcoulombs, separated by 0.05 meters in free space. To find the force between these charges, we'll use Coulomb's law. The formula states that the force equals 1 over 4 pi epsilon naught times the product of the charges divided by the distance squared. Epsilon naught is the permittivity of free space, which equals 8.85 times 10 to the negative 12 coulombs squared per Newton meter squared. Let's substitute our values into the equation. For charge 1, we have 20 microcoulombs, which is 20 times 10 to the negative 6 coulombs. For charge 2, we have 10 microcoulombs, or 10 times 10 to the negative 6 coulombs, and our distance is 0.05 meters. Now, let's solve this step by step. First, 1 over 4 pi epsilon naught equals 8.99 times 10 to the ninth. The product of the charges is 200 times 10 to the negative 12, and our distance squared is 0.0025. Multiplying this all together, we get a force of 719.2 newtons. Now, let's see what happens when we introduce a dielectric medium between the charges. When we add a dielectric medium with dielectric constant K equals 3, the force is reduced by a factor of K. So we simply divide our previous result by 3. To summarize, in free space, the force between our two charges is 719.2 newtons. When we introduce a dielectric medium with K equals 3, the force reduces to 239.73 newtons.